chapter on geology. And what does geology mean? Geology is a study of the structure of the earth. We're going to be talking about teleology, the design and purpose of the earth. First of all, the earth rotates once every approximately 24 hours. If the earth rotated slower than it's rotating, the days would be longer, the nights would be longer. The days would be hotter, the nights would be colder. It has been designed to rotate at the right speed. The tilt of the earth. The earth is tilted. It's not spinning like a top. It's spinning at a tilt of about 23 degrees. If, for example, this model, just say that's the sun. The earth is tilted. This is north, this is south. If the earth was in this position, what season would we be having in the northern hemisphere? Summertime. Then when it moves around here, we're talking about fall. When it moves around here, and we're away from it, then what season we're having? Winter. And then when it gets over here, you're having springtime. So the tilt of the earth gives us our seasons. And that's very important. It's glad that we don't have winter all the time. Or if it was just strictly vertical, we'd have tremendously cold winters in the north and south, and the center of the earth would be a desert. The revolution around the sun, as it revolves around the sun, of course that does it once every 365 and a quarter days. That's what gives us our seasons and our year. The earth is the only place in the universe with the air and the water that we have, which is necessary for life. Why all these special design features on the earth, different and unique from other places in the universe? I just mentioned about air. An animal can survive without water for some time, like 7 days, but you can't survive long without air. And vegetation, we have green vegetation, which is, of course, a lot of what we eat, or at least the animals that we eat also eat vegetation. So these special features are Isaiah 45:18, and it reads like this: For thus saith the Lord God that created the heavens and the earth, God himself formed the earth and made it. He hath established it. He created it, not in vain. He formed it to be inhabited. That's the thing I want to emphasize. God formed the earth to be inhabited. The earth chose special design features so that it could be inhabited. It was designed so that life could exist. It was designed for a place for humans to exist. It says in Psalm 115:16, The heavens, even the heavens, are the Lord's, but the earth hath he given to the children of men. God prepared the earth to be inhabited. God prepared a place for man to exist. Does that make you think of anything? Jesus said, I go away and what? Prepare a place for you. God is preparing another place. He prepared the earth for you to exist. He's preparing another place. Heaven is a prepared place for prepared people. I want to go there, don't you? The earth is the only planet that's covered with air, huge bodies of water, green vegetation for food, all of which are necessary if the earth is to be inhabited. Let's talk about the cross-section of the earth. We're talking now primarily about the solid portion, but before I get into this, let me say that the earth has gaseous, used to call the atmosphere, a liquid portion, which we call the hydrosphere, and it has a solid portion, which we call the lithosphere. This earth is made up of a series of layers. It is felt that it has a crust and a mantle, and inside a core, a liquid core, and a solid inner core. And we'll talk a little more about that later. Now, let's talk about the gaseous portions, the atmosphere. Why is the atmosphere so important? Well, without air, there could be no life. I started to mention this earlier. People have survived without food for more than a month. There have been some miraculous fasts, 40-day fasts, Jesus, Moses, and so forth. took part of it. I don't recommend you going on a 40-day fast. I think that's a miracle fast. Most people can't live that long without food, but they have lived a long period of time. Maybe you could live a month without food. You'd lose a lot of weight, I'm sure. But how long could you live without water, without some liquids? Estimated probably a week. But if I would ask you to hold your nose and see how long you could live without air, most of you couldn't hold your breath longer than just a few minutes. So the air is very important for life. Another thing that's so interesting is the composition of air. Air is made up approximately 1/5, 20% oxygen. It's got almost 4/5 nitrogen. Actually, it's got like about 79%. It has some traces of carbon dioxide, helium, and so forth. But about 20%, a fifth of it, is oxygen. What would have happened instead of there being a fifth oxygen, there'd be a fourth? In other words, instead of 20% oxygen, 25% oxygen. The Earth would probably burst into flames. So not only does it have air, but it has the right composition. I don't know whether any of you, when you took chemistry, whether you had an experiment on oxygen. For example, you heat steel wool. Did anyone take steel wool, heat it in a flame where it's glowing, put it in oxygen, and it burst into flame? Did you do that in chemistry? Very interesting. Steel will burn if there's sufficient oxygen. We certainly wouldn't want the Earth to burn up. So it is the right composition. Also, the wind. The fact that we have wind is very important. It carries the pollutants away from the cities and gives us fresh air. Dust is very interesting. Dust is necessary for rain to fall and for snowflakes to fall, and we definitely need the precipitation. But I think it's interesting also, if there was no dust, the sky would be black. Don't you like the beautiful blue skies, the sun rises and sunsets, these colors? If there was no dust, you would have a black sky. What a dull place. Thank God, God is a colorful God. Reflection of light, different colors. So without dust, the sky would be black. Let's talk briefly about some divisions in the atmosphere. The troposphere is the layer that extends from the surface of the Earth until when the temperature starts to get lower. Most of the air, moisture, dust in the atmosphere and so forth is in the troposphere. This is where most of the weather occurs, in the troposphere. Above the troposphere is the stratosphere, and that extends up to about 30 miles. Airline pilots prefer to fly just outside the troposphere. They want to get beyond that so they get into the place where weather is not as big as a factor. And then there is an ozone layer at the top of the stratosphere, and it's felt that the ozone layer prevents a lot of ultraviolet rays from coming to the Earth. Above that is the mesosphere and the thermosphere, and it's in the thermosphere where they have what we call the northern and southern lights. Aurora Borealis, which you probably can see here in Minnesota at times. I've seen it from airplanes before. I'm not going to get into a whole lot of details. There's also the ionosphere, and there's the exosphere, and the satellites usually are orbiting in the exosphere because that's where there's almost no air resistance, very little air. By the way, the Aurora Borealis and the Aurora Australis, as the southern lights are called, they feel like these are caused by the Earth's magnetic field interacting with the solar winds. And the displays from this are very colorful, and they can change even in the same night. Now let's talk about the hydrosphere. The hydrosphere is the liquid portion. We've already mentioned in this class several times that the Earth is covered with over 70%. The oceans themselves are about 70% of the Earth's surface. There's also lakes and rivers and so forth. So there's a lot of the Earth covered by the hydrosphere. Now, if you went out on the ocean, if the portion to your left is the land and the blue line is the water line, you have what is called a continental shelf. You have a continental slope and a continental shelf, And that can extend out quite a ways. Sometimes the continental shelf is just a few hundred feet. Sometimes it can be as far as 200 miles, rarely more than about 600 feet deep. Now, outside that is another slope, and that goes down to deeper levels. That's called the continental slope. And there are deep ocean basins. The deepest ocean basin that I know of is the Mariana Trench. That's over 7 miles deep. They have gone down there, and there are also sea mountains. I don't know how far Jonah went, but Jonah says he went down, didn't it say, to the bottom of the mountains? So that whale must have taken him quite a ways, because that wasn't as deep in the Mediterranean Sea as there are in the oceans. So there's very deep ocean basins out there. These have been investigated by it's not really a submarine, but it's sort of like a submarine. It's a bathyscaphe. It's designed for deep sea observation. This bathyscaphe, particular one I'm going to show the next picture, this one is the one that has set the record for the deepest any vessel has ever gone. It has gone over 6 miles deep, 35,800 feet deep. On board of Jacques Card and Lieutenant Don Walsh's picture of them, a U.S. Navy photo. Now, why is water essential? I mentioned how essential air was. You can't survive without breathing. Man and animals also need water to survive. They use plants, and they use water, plants do, to make food which man eats. Water also makes soil by erosion and expansion. One of the unusual properties of water is that when it freezes, it expands, and that gives great pressure, which can crack rocks, crack up into soil. And then water provides a tremendous temperature control. We talked about controlling the temperature of the body, but it controls the temperature in a lot of places. Places like England, and I lived in England for a couple of years, get very little snow, and yet it's way up there as far as geographically. It's far farther north than Minnesota is. I live in Chula Vista, which is 7 miles from Mexico. We do not have air conditioning in our house. We've lived there 2 years. I've slept every night under a blanket. I'm 7 miles from Mexico. Why? How come it's not so hot down there like Texas or something? Because you're near the water. And our house happens to get an ocean breeze. Chula Vista this summer, I think the highest temperature it got was 80 degrees. The lowest temperature you'll probably get will be about 45 in the wintertime. What keeps that kind of constant temperature? It's because of the water. A lot of places like Norway, Scandinavia, Finland, and so forth, I know they're cold, but they're not near as cold as they would be if they weren't near water, which provides temperature control. Water has some very unusual properties which are a tremendous blessing to us. Let's talk about some of these properties. I'm going to use some terms that I use when I taught chemistry, but I'll try to define them to make them simple. Water has a very high specific heat. The definition of specific heat is the heat required to raise 1 gram of a substance 1 degree centigrade. Water requires 1 calorie of heat to raise the temperature of 1 gram of water 1 degree centigrade. It is very high. Almost every other substance, because I don't know any other substance that has that high of a specific heat. What does that do? That prevents sudden changes in temperature between day and night. That's why you don't have the nights getting very, very cold and the days very hot, because in the daytime the water absorbs the heat. At nighttime it gives off the heat, and it prevents sudden variations in temperature, especially in island areas. High latent heat of vaporization. When you get hot, I have a picture one place of Muhammad Ali's back, of the perspiration, of the beads all over. Well, heat of vaporization. This is the amount of heat required to evaporate 1 gram of a liquid. Water happens to be 540 calories per gram, a very high amount of heat. So every gram of sweat that evaporates takes away 540 calories of heat from you. That's a very important phenomena in cooling plants and animals. plants, it's called transpiration. In animals, it's called perspiration. Water also has a very high heat of fusion. Heat of fusion is the heat required to melt 1 gram of a solid at its melting point. Ice requires 80 calories per gram. Again, a very high amount compared to other substances. Why is that important to us? The first hot day of spring, all the snow would melt otherwise, and we'd have floods just messing up everything. But many of our mountains, they're snow-capped all the way to the end of summer. And it provides a constant stream of water rather than all going over, down the falls at one time and you're running out of water the rest of the time. So that's a very important thing. It also prevents the oceans from freezing up because it takes a lot of heat to be removed in order for something to freeze. Farm wives use that property. They'll often put a tub of water in a fruit cellar. That prevents the jars of jelly and so forth from freezing on bitterly cold nights. Before the water can freeze, it's got to give up a whole lot of heat. And oceans don't freeze up in the winter a lot because of that property. Another very unusual property is that water expands when it freezes. Water contracts until about 4 degrees centigrade and then it starts expanding. And what that does is that causes the ice to float and lakes to freeze over at the top. You could perform an experiment on most stuff, like paraffin or anything else, let it cool, and the solids go form on the bottom. Ice forms at the top. Why is that so important? Extremely important. What it does is the ice layer forms at the top and it prevents the rest of the lake from freezing. If it weren't for this property, this winter in Minnesota, every single lake would freeze over solid. Every fish would be frozen fish and die. Well, it enables fish to survive. Very important. And I just want to say, I have actually taught this in chemistry because we have part of water, but I have to resist, even at secular college, to giving God the glory right in the middle of the classroom because God put these properties in. Although outside the class, I certainly have shared some of these feelings about it being a miracle. It's also a universal solvent. That helps a lot in washing clothes. But probably more important than all is that most things, even like blood, it's a solution. Your blood has different things it's carrying about in solution, your sugars, proteins, and so forth. The blood in the body is mostly water, and it carries chemicals of life throughout the body. And this is what I really like about it, abundant and cheap. We can still go to most places and get a drink of water free. You don't have to pay. Don't have to go to the machine there and put $1 in to get a drink of water. Now, I know a lot of people are paying that for bottled water, but most of the places you go here, you can get, the city systems are adequate to drink water out of. 70% of the earth is covered with water. It's not a rare chemical. It's available to most everybody, and not only in the oceans, but lots of times you just dig a few feet under the ground, and you could dig a well, and there is water. Aren't you glad that water doesn't cost $20 a gallon? It's available. I know we have water bills, but they're not high compared to other chemicals. And then we use it to put out fires. Water doesn't burn at ordinary temperatures. It cools materials below the kindling temperature, and it enables us to put out fires.
Water has an unusually high boiling point for its molecular weight. Most materials with this low of a molecular weight are gases. This high boiling point prevents water from boiling away.
Another property of water is what's called surface tension. You probably have put little tubes in water and seen what's called a capillary action. This enables the water to go up the trees. Water, you might think, is divine gravity. It climbs up, provides water to the top of the trees. That feature of being able to go up a small tube The attraction of the water to the lining of the tube is called surface tension, and that enables what's called capillary action, which enables water to rise up. It also enables the water strike to, quote, walk on water. Also, when you wax a car, if you wash it, what does the water do? It beads up. You could do this with wax paper. Put drops of water on the wax paper and it'll bead up. That's called surface tension. And the most important feature of surface tension for us is the ability to, so say, quote, climb up the trees and plants and so forth so they get water. Another important feature of the Earth is gravity. Why is gravity important? If it wasn't for gravity, we would fly off just like a mud ball off of a stick. It keeps us onto the Earth. It also keeps the water from flying off the Earth. It also keeps the atmosphere. If it wasn't for gravity, the air would escape into this space. And it keeps the Earth, Moon, and other planets orbiting in space. If it wasn't for gravity, oceans would probably evaporate. Lower gravity would cause us to orbit further away from the sun, would make the Earth much cooler. If it was higher gravity, our orbit would be closer and the Earth would be too hot. Isn't it marvelous? God has chosen the right amount of gravity. The lithosphere, that's the solid portion of the Earth. Remember, the hydrosphere was the liquid portion and the atmosphere, the gaseous portion. On the outside of the Earth, there is felt to be a thin skin, like an onion skin on the outside of an onion. That's about percentage-wise, covering the Earth. Could be, they think, maybe as deep as 20 miles. Now, when I get into this portion, really we don't know about it. The deepest mine shaft is about 2 miles deep, and the deepest in oil and gas wells is about 5 miles deep. So really, when we talk about the Earth, the center of the Earth, the temperatures and so forth, we're really kind of speculating. As far as sea goes, the guys in that bathyscaphe went down to like about 6 miles. That was in the ocean. But as far as digging into the crust, about 5 miles is all we actually have experimentally. Highest part of the Earth is Mount Everest, 29,000 plus feet. Lowest spot is the Dead Sea, which is a little over 1,000 feet, 1,299 feet below sea level. It must get real hot there. We have Death Valley in California where it gets very hot. That's below sea level too. So man has never even penetrated the Earth's crust. And part of the problem is as you go down, the temperature increases. That they know, but how hot it gets, we don't know. We do know because of volcanoes that erupt that is molten below there. Some people feel like the temperature in the deepest part of the crust may reach 1,600 degrees Fahrenheit, which is hot enough to melt rock. Below the crust is thought to be what's called the mantle. That's believed to go down about 1,800 miles, believed to increase in temperature to about 4,000 degrees Fahrenheit. Then there's the core of the Earth, the outer core, which is assumed to be about 1,400 miles thick, thought to be melted iron and nickel. Part of the reason they come to these ideas is because the Earth has a magnetic field, and iron and nickel are usually involved in magnets, and believed to have an inner core where the temperature is as hot as 9,000 degrees Fahrenheit. Very hot. Someday the Earth is going to melt. This Earth is going to be destroyed by fire. How it will happen, I don't know. Also, the Earth has a magnetic field. This is probably molten iron in the center of the Earth. Now, there are some categories of rocks, 3 major categories of rocks in the Earth's crust. Most of the Earth's surface is sedimentary rocks, mostly laid down by water and then cemented together. Common sedimentary rocks are things like limestone, sandstone, and shale are examples of sedimentary rock. And then there are a few rocks which are called metamorphic rocks, and that's rocks that are believed to have been igneous and sedimentary and that they have been changed by heat and pressure. For example, limestone is felt to be able to change to marble. That would be a metamorphic rock. Bituminous coal changes under proper heat and temperature to anthracite coal, be an example of a metamorphic rock.